So we looked at our solids, and now we're going to have a look at volume. And the easiest way to think of volume is the amount of space it takes up. Another way is to, say for instance this little rectangular prism, how many little centre cubes would you need to make that up? That's another way of thinking of volume. Now we can either measure volumes for some things in centre cubes, so this is where each edge of the cube has got a centimetre on each edge. For larger things you can imagine a cubic metre. Now each edge of that is as long as a 1 metre ruler out of a maths classroom there. And for tiny things you can go to a square millimetre, which is sort of drawn there. That's probably still a bit too big to be a square millimetre there. And look, for massive things you could go to a square or cubic kilometre, but there's very few things on Earth that you'd actually use to use that as the appropriate measure. So in example 1 we're going to choose either cubic millimetres, cubic centimetres, cubic metres or cubic kilometres. Work out which is the best unit to... Okay, so if we had to say a room, say D16 or D5, whatever room you like, if you're going to work out its volume, so you notice that the edges of the room, if you were to measure it, you'd be measuring the dimensions in metres. And so it gives you a good idea that you're going to measure the volume in cubic metres. If you were to measure a textbook, you're probably going to be measuring each edge in centimetres, so its volume in cubic centimetres. Grains of sand, look, you'd be measuring each of them in millimetres, so their volume in cubic millimetres, even though there's 20 of them. Again, truckload of sand, you're probably going to be measuring the bed of the truck in metres. There. A wheelbarrow, look, you could be measuring that in centimetres or metres. Okay, so you'd accept either one for that one there. There's no one right or wrong answer. And a matchbox. Again, a matchbox, you could be measuring it in millimetres or centimetres. So again, you've got two acceptable answers there. You notice we haven't used cubic kilometres in any of those examples. Okay, so we now need to work out how many centre cubes would be used to make this up. And you can see that there's 3 along each edge there, and looking back there's 1, 2, 3, 4, 5, 6, 7 going back. So you can see each layer, so each layer, this bottom layer, would have 3 times 7, in other words 21 on that bottom layer. There's 2 layers, okay, there's another layer up here. So we need to times that by 2. And if you multiply that together either in your head or on a calculator, you'll get 42 cubic centimetres. Similarly here you can see we've got 2 along each edge. And so all we need to do is just go 2 times 2 to work out how many cubes are along the bottom. And then times that by 2 because there are 2 layers. So 2 by 2 by 2. In other words, 2 cubed. You notice that's a cube and we've cubed the number. That's where the name comes from. 2 times 2 times 2, or 2 cubed, that'll give you 8 cubic centimetres. Okay, then have a go at today's work. Okay, so again we're choosing the most appropriate unit to measure. So a soft drink bottle. Again, if you were to measure a soft drink bottle, you could either be using centimetres or millimetres. Probably a bit better to use centimetres there, so I'll just write the one answer there, but millimetres cubed would be okay. A swimming pool, look, you're probably going to be measuring it in metres, so the volume in cubic metres. Now the earth, if you were to measure the earth, you're going to be measuring it in kilometres, so it's volume in kilometres cubed. A school bag, look, you're probably going to be measuring in centimetres. A large hall, you're probably going to be measuring in metres, so the volume in metres cubed. The inside of a car, look, you could be measuring it in centimetres or in metres there. A warehouse, you'll probably be measuring that in metres. The moon, again, probably measuring in kilometres, so the volume in cubic kilometres. A brick, again, look, you're probably going to be measuring in centimetres, but you could be measuring in millimetres. Soccer ball, again, probably centimetres there. Hot air balloon, probably metres. And a golf ball, look, either millimetres or centimetres for that one there. Okay, we just need to count the number of cubes here. So here you've got 3. Look, you should be writing cubic centimetres at the end, but you can just write the number if you like. Here we've got 4, here we've got 5, here we've got 2, 4, 6. Here we've got, let's say 4 lots of 2 is 8 plus 2 is 10. Here we've got 2 cubed, which is equal to 8. Now this bottom layer is going to have 4 times 3, which is 12, plus this extra 2, which is 14. Probably the easiest way to deal with this is deal with this first layer here, which has got 5 in it, and times it by 3. And 5 times 3 is 15. Again, do this front layer, which has got 6 in it, and 6 lots of 2 is equal to 12. Again, the front layer's got 4. 4 times 2 is 8. Now this one here, we can presume that we've got 2 of these layers with 3 into each there, so we've certainly got 6. We've certainly got a 7th one. No, look, that's all we can see, but there could be another one sort of back in behind. Actually, no, they couldn't. Actually, no, they couldn't be. That's all we can do there. With this shape here, you can see that on this furthest layer we've got 4 on the bottom and this one up here. So there's 5 there and there's 2 layers like that. So it's going to give us 10, plus the extra 3 in here, which is 13, plus the 2 on the end makes 15. Okay, so for this particular rectangular prism, we've got 2 along this edge by 3. So each layer has got 6 centre cubes in it. There are 4 layers, and 6 times 4 is equal to 24. Look, we'll assume they're centre cubes, but it hasn't said. Here we've got 2 times 3 times 2. That'll give us 12. Here we've got 3 times 6 times 1. That's just going to give us 18. Here we've got 3 times 3 times 3, or 3 cubed, which is 27. Now it works even though they haven't been divided up into cubes. See here on this bottom layer, we could work out how many cubes we need by going 16 times 3, and then multiply it by the number of layers we'd have, which is 9. Oh, this will test me out. I better go to my calculator here. I don't know what 48 times 9 is. I mean, I could work it out, but I'd just embarrass myself there probably. Okay, so that's going to be 432. Now, look, they've said FT for feet, so technically that would be in cubic feet, but if you just want to write 432, that's fine. Don't know why I'm putting the calculator away. Again, I'm just going to multiply those numbers together. So looking there, so I'm going to go 15 times 12 times 17. That's going to give us an answer of 3060. In this case, it's going to be in cubic inches. And lastly, we're going to go 7 times 6 times 10. Well, I can do that in my head. That's 420. This time it'll be in cubic yards. So we've used some imperial measurements there because these sheets are made up, or some of these sheets are made up in the United States. Okay, this time it's drawn slightly differently, so we no longer have it isometrically, but same idea. We've got 4 along this edge times 3 along this edge times 7 along that edge there. 4 times 3 times 7, that'll give us 84. Now look, it said cubic feet there, but if you just want to leave it as 84, that's fine. Then we've got 6 along this edge by 2 by 6, that'll give us 72. We've got 3 times 4 times 5, which will give us 60. We've got 5 times 2 times 3, which will give us 30. We've got 6 times 4 times 2, which will give us 48. We've got 2, 4, 6, 7 by 2 by 7. That'll give us 98. We've got 2, 4, 6, 7 by 3 by 3, which will give us 63. 3 by 2 by 2, 4, 6, 8, 9. That'll be 54. And 3 times 5 times 6, it's going to be 90 there.